Hello viewers, I am Kausalya. Today we are going to discuss about Kirchoff's laws. So here basically there are two laws. One is known as Kirchoff's current law and another one is known as Kirchoff's voltage law. Right. So both these laws are used to solve the electrical networks. So first we start our discussion with Kirchoff's first law or Kirchoff's current law. So here the statement here is the sum of currents flowing towards a junction is equal to the sum of currents flowing away from it. So here you see totally we are having 5 currents and they are named as I1, I2, I3, I4 and I5. Right. So here this is a node or junction or a meeting point. Okay, whatever may be. So here in this case, the currents, that is the sum of currents flowing towards the junction is equal to the sum of currents flowing away from the junction. Right. So here this is our junction. So can you tell what are all the currents that flow towards the junction? So here we are having I1, right, I4 and I3. Right. These three are the currents that flow towards the node or junction. And what are all the currents that flow away from the junction? I2 and I5 are the currents that flow away from the junction. Right. So here mathematically we can write this as, you see, I1 plus I4 plus I3. Right. That is, these are the currents that flow towards the node or a junction. So sum of the currents. So we are going to add these three currents. So I1 plus I4 plus I3 is equal to I2 plus I5. That is the sum of currents flowing away from the junction. Right. So here for example, we can consider 2 plus 4 plus 4. Right. So totally the current is equal to 10 amps. So here this can be sum 7 plus 3. So the sum of incoming currents is equal to the sum of outgoing currents. Right. This is our first law. Hope I have made the concept clear. Right. So this is basic. The sum of currents coming towards the junction is equal to sum of currents flowing away from the junction. So now we proceed with Kirchoff's second law. It is known as voltage law. Right. So here we will be discussing about the circuits, that is a closed path. Right. So here we are having a voltage source. It is denoted as E and we are having three resistors, right? R1, R2, R3. They are connected in series and I is the current that flows through the circuit. Right. So here the second law states that sum of potential drop is equal to the sum of potential rise. Right. In other words, summation of voltage drop is equal to summation of voltage rise. Right. So here now consider this closed path, that is A, B, C, D and A. Right. So now here we are going to consider each branch and we are going to discuss whether there is a potential rise or there is a potential drop. Right. Because here you see we have to sum all the potential drops and we have to sum all the potential rise. Right. So here from this circuit, can you tell how many branches are there? For example, here you see AB is a branch, BC is a branch, CD is a branch and again DA is a branch. Right. So totally this circuit has 4 branches. Right. We start with AB. So first list out the total number of branches. Right. AB, BC, CD and DA. So here whenever a current flows through the resistor, what happens? It produces a voltage rise or voltage drop. It produces a voltage drop. Right. Therefore this segment, that is this branch, produces a voltage drop. What is the value of voltage drop? So what is meant by voltage? It is equal to I into R as per Ohm's law here. Therefore, the voltage drop along this path AB is nothing but I into R1 because the current flowing through this path is I here, right? Therefore, I into R1. So, it is a drop. Now, consider the branch BC. So, again the same current I flows here. Then what about the drop here? The drop here is I into R2, right? Similarly, for CD, again the same current I flows. Then what about the drop here? The drop is I into R3, right? And again when you look at this branch DA, right? So here you see the polarity. So here the current flows from minus to plus, that is from lower potential to higher potential. Therefore, this is considered as a voltage rise, right? So this is what written here. Okay, these are the potential drops and this is your only potential rise. So as per Kirchoff's voltage law, what is the law here? The sum of potential drop is equal to sum of potential rise. So here what are all the potential drops? IR1, IR2 and IR3 are the respective potential drops along R1, R2, R3. So here what is the potential rise? That is E, right? So this is our second law. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.